On November 19th, millions of people around the world watched a blue-framed countdown clock fade into the familiar seal of a space agency that has become almost synonymous with truth. They were promised a closer look at 3I Atlas, the strange interstellar visitor that had slipped into our system carrying a triple-braided tail and a storm of questions. Instead, they received a soft-spoken reassurance that everything was ordinary. The feed cycled through the same handful of images, slightly blurred, slightly overexposed, always just a little too vague. Officials repeated the word comet as if it were a soothing charm, while the chat windows filled with people asking why the newest data looked suspiciously like frames from October. Somewhere in between the carefully chosen phrases and the missing details, a different kind of signal seemed to emerge, not from the object in space, but from the way the story was being told. It sounded like a quiet request for the public to lose the interest and move on. If you are here tonight, you are probably someone who did not move on. You are someone who noticed that the official briefing skipped past awkward questions about size, structure, and the strange persistence of that triple tail. You might have heard Avi Loeb hint on national television that even a spacecraft drifting through space could collect a shell of ice and dust and start to look like a comet. You might have wondered why a solar storm forecast to wash over the region of 3I Atlas a few days later did not earn even a passing mention in the polished script. This video is for the part of you that felt those details lodge in your mind like tiny splinters of doubt. Here on this channel, we move slowly through those splinters. We take the official narrative and hold it up to the light, not to shout over it, but to gently see where it becomes translucent. We are not here to panic you. We are here to give you a place where wonder, suspicion, and sleep can coexist in the same quiet breath. As you listen, you are free to agree, to disagree, or simply to float above the puzzle and let the patterns form in the background of your thoughts. If you choose to stay, I invite you to be part of a small and patient community that refuses to let the sky be summarized in a single word. You can support this work by listening all the way through, by leaving a simple comment with your thoughts, and by subscribing so that you do not miss the next piece of this unfolding dossier on 3I Atlas. Share this video only if it feels right to you, perhaps with someone who also sensed that something about the official story was slightly out of tune. Together, in a very quiet way, we can keep watch while others fall back to sleep. Now, dim the lights. Imagine the scene on November 19th as the live stream truly begins. Studio cameras are perfectly framed. A host smiles with carefully measured warmth. On the screen behind them, 3I Atlas appears as a tiny glowing blur against the black of space, a pale green smudge wrapped in a halo of light. Names and titles flash across the lower third of the screen, program managers and mission scientists whose job tonight seems less to explore a mystery and more to close a case. They speak of trajectories, of expected outgassing, of how reassuring it is that the object behaves like other long-period comets. Every phrase is technically correct, yet somehow it all feels as if a curtain has been hung in front of the real questions. As the broadcast unfolds, one pattern becomes impossible to ignore. The word comet is repeated again and again, not as a neutral descriptor, but as a kind of anchor that the speakers keep returning to whenever the discussion drifts close to the unknown. When a viewer asks about earlier suggestions that 3I Atlas might be larger than first estimated, The answer loops back to how typical its brightness curve appears for a comet of its supposed size. When someone mentions the unusual triple tail, the reply quickly reframes it as a lovely but harmless display of dust and ion streams. In place of direct engagement, there is a slow drifting away from each sharp question, like a camera that refuses to focus. Behind the scenes, we know that 3i Atlas did not appear from nowhere. By the time of the live stream, observatories around the world had been tracking it for weeks. Data on its speed, its changing brightness, and its shifting tail structures existed in abundance. Yet the visuals chosen for the broadcast come from a narrow slice of that timeline, primarily from early October, when the object was still relatively far and faint. High-resolution frames from more sensitive instruments are mentioned in passing, but never shown in full clarity. Instead, the audience is given slightly softened composites that smooth out edges and wash away subtle asymmetries in the coma. For most viewers, this presentation is enough. They hear calm voices, see official logos, and feel the gentle relief of being told that the cosmos is behaving as expected. The disappointment is almost comforting. Nothing strange, nothing urgent, nothing that might demand a shift in how we think about visitors from between the stars. But for a minority of watchers, perhaps including you, the disappointment feels manufactured. It is as if the broadcast has been tuned to leave you just satisfied enough to close the tab, while quietly training you not to ask for sharper images or harder numbers. There is a moment, usually about halfway through, when this feeling crystallizes. A host refers to 3i Atlas as a once-in-a-lifetime opportunity to study an interstellar comet, then immediately reassures the audience that this object confirms what models already predicted. In that quiet contradiction, the tension becomes audible. How can something be both an unprecedented visitor and a routine confirmation at the same time? In the space between those two statements, a different possibility starts to flicker. Maybe the opportunity is not to confirm a model, but to encounter something that does not fit any existing category, something that would require a change in language rather than a repetition of familiar terms. At a more technical level, a few numbers slip through that are worth holding on to. The nucleus of 3i Atlas is described as measuring roughly 5 or 6 kilometers across, a size that sounds safely modest. The speaker reminds the audience that many comets fall within this range. What is not explored is how that estimate depends heavily on assumptions about how reflective and how active the surface really is. If the outer shell is unusually bright or unusually thick, the true mass and structure could differ dramatically from the friendly mental picture of a small icy snowball drifting harmlessly by. This is where the first layer of grounded speculation begins. If an object wished to appear smaller and more ordinary than it truly is, it would only need to control the thickness and brightness of its surrounding coma. A dense, engineered cloud of dust and gas could be tuned to mimic the luminosity profile of a textbook comet while concealing a much more massive or complex core. The numbers quoted in the briefing would not be lies in the strictest sense. They would simply be measurements of the shell rather than the thing concealed inside it. The more unsettling leap comes next, and it is one we will handle gently. Suppose for a moment that 3i Atlas is not only using natural physics, but is using them with intent. Suppose its outgassing is managed in a way that shapes the tail into a triple plume, not because it must, but because that pattern just happens to confuse simple models and averages out into something interpretable as noise. In that scenario, the live stream's insistence on ordinariness would not just be a public relations choice. It would be a defense mechanism, a way of keeping the conversation anchored in the safe swallows of familiar language, while something far stranger passes quietly overhead. Tonight, in this first part of our journey, we are not claiming to know that this is true. We are instead tracing the outline of a feeling that many people described after the November 19th broadcast. A sense that the event was less about sharing discovery and more about steering perception. As we move deeper into this dossier, we will follow that feeling into the images themselves, into the solar storm that no one wanted to talk about, and into the lingering question that keeps echoing behind all the technical terms. If the skin of Three-Eye Atlas is all we are meant to see, then what kind of story begins when we dare to ask about the core? If the live stream on November 19th felt like a performance meant to close the case, the images at its heart were the props that made that performance possible. On the surface, they seemed innocent enough. A small glowing knot, slightly stretched, floating in a grainy black field. A caption in the corner quietly labeled it as Three-Eye Atlas and listed a date from early October, as if the image were nothing more than a routine snapshot preserved for the record. For most people, the visual message was simple. Here is the object. Here is its fuzzy outline. There is nothing to look at for long. But when you stop and sit with that blur, letting your eyes soften the way you would when watching a dim star from a dark field, questions begin to rise from inside the pixels themselves. The spacecraft that captured one of the keyframes shown in that briefing, an orbiter around Mars, is not a clumsy or outdated machine. It has cameras sharp enough to pick out the tracks of rovers on the Martian surface, to see boulders and dust ripples only a few meters across from hundreds of kilometers overhead. When that kind of instrument turns toward an object like Three-Eye Atlas passing through the inner system, you would reasonably expect exquisite detail. Even if the core of Three-Eye Atlas is wrapped in a bright coma, the way the light falls off, the way the central region saturates, should carry structure that a billion-dollar sensor can easily record. Yet what we were given instead was a bright, nearly featureless patch that could almost have been drawn with a soft brush in a graphics program, surrounded by an overexposed haze that swallows any sense of where the solid ends and the gas begins. People who study images for a living know that you do not have to see a sharp edge to estimate a size. You can count pixels, measure how brightness changes from the center outward, and compare that profile to models of how light spreads when it is smeared by optics and motion. When independent analysts treated the Three-Eye Atlas frame this way, working from the same public image, something odd emerged. The luminous region where the object sits covered a span that, once translated from pixels to kilometers using the stated scale, came out closer to 20 kilometers across than to 5. The explanation is not automatically sinister. In comet science, the word nucleus often refers to the solid heart, while the bright patch can include layers of expanding gas. You can still argue that the true core of Three-Eye Atlas is only 5 or 6 kilometers wide. But what cannot be ignored is that the picture used to reassure the public subtly invites them to fuse the idea of nucleus with the soft glowing blob, to unconsciously equate the small number with the large, unresolved patch. Here, the grounded speculation begins to take shape. If the bright region spans tens of kilometers, then the volume in which any hypothetical core could hide is much larger than casual viewers are led to imagine. A compact, dense object, only a few kilometers wide, could sit inside that brightness, like a seed inside a cloud, its presence influencing the shape of the coma without ever being directly resolved. The official narrative focuses on the smallest plausible number because small things feel less threatening, less worthy of attention. Yet the optics do not care about our comfort. They simply report how much light comes from how large an area. When the two stories diverge, it is worth asking, which one is being adjusted for emotional impact? To get a sense of how this can happen without overt lying, imagine you are asked to describe a distant lighthouse seen through thick fog. You could choose to speak only of the lamp itself, a few meters across, or you could admit that everything the eye sees is the glowing column of haze, tens of meters wide. Both descriptions are, in a narrow way, true. But if your goal is to minimize alarm among sailors who must decide whether to alter course, you might dwell on the smaller number, the one that makes the obstacle feel tiny and abstract. The image of Three-Eye Atlas functions in a similar way. It shows the fog and names the lamp, trusting that the viewer will not pause long enough to separate the two. The imaginative leap arrives when we apply this metaphor back to the mystery at hand. What if Three-Eye Atlas is not simply surrounded by an accidental fog, but is actively shaping its luminous envelope? In that case, the mismatch between the claimed nucleus size and the glowing footprint in the image becomes more than a quirk of terminology. It becomes a design choice, a shell that is just large and bright enough to soak up sharp features, just chaotic enough to keep any internal geometry from imprinting itself on the sensor. The triple tail, emerging from this overexposed cocoon at carefully spaced angles, begins to look less like a random spray and more like the hint of a hidden framework doing its best to stay behind the curtain. Of course, there is a sober counterpoint. Cameras saturate. Exposures are tuned for safety rather than drama. Data pipelines apply automatic filters intended to remove noise, cosmic rays, and artifacts. Any one of these steps could broaden and soften the image of Three-Eye Atlas without human hands deliberately manipulating the result. This is why responsible inquiry must tread carefully. The question is not whether a single processed frame proves that Three-Eye Atlas hides something unnatural. It does not. The question is why, out of all the possible ways to present the data, the public is repeatedly shown the version that erases complexity and shrinks the sense of scale. There is another detail that often goes unmentioned. In technical documentation and internal talks, scientists sometimes discuss the brightness of Three-Eye Atlas in terms of ranges and uncertainties. They know that albedo, activity level, and viewing geometry can all change the translation between light and mass. In the live stream, these uncertainties are smoothed into a single reassuring estimate, spoken once and then treated as a settled fact. For someone half listening from a couch late at night, this creates a steady, sleepy rhythm. The object is this big. It behaves like this. It fits here in our catalog. There is no need to wonder whether a different assumption might inflate the invisible space within that fuzz. As you lie back and picture that blurred patch of light, suspended somewhere between Mars and the Sun, it might help to hold two images in your mind at once. In one, Three-Eye Atlas is exactly what the calm voices say it is, a natural shard of ice and rock wrapped in its own evaporating skin. In the other, it is something denser and stranger, using that very same physics as camouflage, tuning its coma to produce a comforting profile whenever a human camera looks its way. Both scenarios live inside the same pixels. Both can be made to fit the data if you lean on one assumption or another. The deeper, unsettling question is this: when a powerful institution chooses again and again to favor the interpretation that lulls the public back towards sleep, is it because the universe is truly that simple, or because complexity, once admitted, becomes impossible to control? As we move on, we will leave the flattened frame behind and turn toward how 3i Atlas behaved when a storm from the sun washed over it. If the image is the skin of the story, then its response to that storm may bring us one step closer to whatever waits at the core. There is a quiet difference between what a camera sees and what the world is invited to see. When you look at the promoted image of 3i Atlas from the Mars orbiter, you are looking at the end of a long chain of decisions. Light leaves the object, crosses millions of kilometers, strikes a detector, becomes numbers, flows through software, passes across the desks of analysts and public affairs officers, and only then condenses into the single, softened frame that glows on your screen. At each step, someone or something has to decide what counts as signal and what counts as noise, what to enhance and what to suppress, what is safe to show, and what might raise too many questions. In principle, the early stages of that chain are purely technical. Detectors collect not only the light from 3i Atlas, but also electronic hiss, cosmic ray hits, and subtle quirks of the hardware. Calibration pipelines subtract bias levels, correct for uneven sensitivity, and remove sudden bright specks that appear in a single exposure and never again. These steps exist so that scientists can see the universe more clearly, not less. But any automatic system that learns to erase sharp, isolated features in order to clean up the view also carries a hidden risk. If an object ever produced real, narrow structures or abrupt edges that did not resemble anything expected from a natural comet, the algorithms might treat them exactly as they treat artifacts. They would vanish into the background, not because someone issued a direct order to hide them, but because the tools were built with a specific picture of reality in mind. Later, when those cleaned frames are prepared for a general audience, another layer of filtering begins. This one more psychological than physical. Raw space images can look harsh and unfamiliar. Bright cores saturate while faint tails barely rise above the noise. Public-friendly versions often compress the dynamic range so that the brightest parts do not blow out and the darkest regions are pulled up into gentle gray. Noise reduction smooths graininess into a soft glow. Color balances shift to create a more aesthetically pleasing tone. None of this is unique to 3i Atlas. It is common practice in many missions. What sets this case apart is how thoroughly that smoothing removes any hint of substructure in the heart of the object. Even though the same spacecraft is known to preserve very fine patterns when looking at worlds that are easier to explain. Imagine, for a moment, a less polished version of the same frame sitting deeper in a server, a version where the inner brightness of 3i Atlas spills across a few pixels more, where gradients are steeper, where faint asymmetries cling to one side of the core. To a trained eye, those asymmetries might whisper about jets, about uneven activity, perhaps even about something more rigid moving inside the coma. To an untrained eye watching a live stream, they would simply look messy. When someone chooses the image that will represent 3i Atlas to millions, it is easy to justify reaching for the tidy, rounded version. It reads faster, it reassures more effectively, it leaves fewer awkward shadows in which speculation can grow. The grounded speculation begins when we think about how these choices line up with the spoken narrative. In the November briefing, the speakers emphasize how well 3i Atlas conforms to expectations for an interstellar comet. They refer to brightness curves that match models, to tail behavior that does not force any radical revisions. If that is the story you wish to tell, it is convenient to show an image that offers no obvious points of contradiction. A perfectly soft core and a featureless glow encourage the viewer to accept the word comet at face value. There is nowhere for the eye to catch and say, that bump looks strange, that edge looks too straight, that gap in the halo makes me uneasy. In that sense, blur is not only a product of optics, it is a tool of framing. At this point, the imaginative leap invites itself in, and we will let it enter slowly. Suppose you were tasked, not with an understanding 3i Atlas, but with ensuring that nothing about it would disturb the wider public. You would not need elaborate conspiracies. You would only need to tune existing systems. You might set automated filters to be slightly more aggressive near the brightest parts of this particular target, so that any high-frequency features are classified as noise and smoothed away. You might encourage image processors to prioritize aesthetics over fidelity, favoring a single neat halo over a more complicated, grainy truth. You might quietly decide that the raw frames will remain in archives that few outside specialists will ever see, while the world receives a carefully curated portrait that supports the comforting script. There is no document that proves such a directive exists. There may never be one. Yet, when we look at the image of 3i Atlas that was chosen to represent a once-in-a-generation interstellar visitor, and we compare it to what the hardware is capable of under other circumstances, the gap between potential detail and delivered softness becomes a character in the story all by itself. It is as if the camera is whispering at full resolution, and the released frame is that whisper heard through a thick wall. The content of the message may still be accurate in outline. There is a bright object. It has a coma. It is moving along a calculated path. But the texture that might hint at deeper structure has been sanded down to the point where only one narrative feels natural to accept. This is where an unsettling question arises, not about villains in dark rooms, but about the culture of institutions that must manage both discovery and public trust. When faced with ambiguity, do they lean toward images that amplify the unknown or toward ones that soothe and simplify? If a particular processing choice makes 3i Atlas look more ordinary, even at the cost of losing potentially interesting structure, does anyone in the chain feel a duty to defend the complexity? Or does the gravity of habit pull everyone gently toward the blur? These questions linger not as accusations, but as quiet reminders that data can be honest and still be guided into certain shapes. As this first section of our dossier closes, we are left with a layered picture. At the core are photons that have traveled across space from 3i Atlas. Around them are calibration routines, smoothing kernels, dynamic range curves, and human preferences. Around all of that sits the narrative of a harmless comet, spoken in soothing tones over a carefully selected image that asks nothing of the viewer except a nod. In the next part of our journey, we will step outside that official filter and look at what happens when different eyes and different instruments watch the same object without the same obligation to maintain a script. Where institutions offer blur, the night itself sometimes offers unexpected focus. On some nights, while official streams replay their polished segments on demand, the real sky is still there, unedited, hanging above people who have nothing more than a modest telescope, a sensitive camera, and a refusal to look away. They are teachers, technicians, students, retirees, scattered across suburbs and farmland and mountain ridges. They do not have press officers or scripted talking points. What they have instead is time, patience, and the kind of quiet stubbornness that makes someone sit under cold air for hours, nudging a small mount to follow a faint moving smear that most of the world has already been assured is ordinary. For them, 3i Atlas is not a symbol in a briefing. It is a pale, living thing that drifts across their laptop screens, changing shape from night to night in a way no still frame can ever fully capture. By the time of the November 19th broadcast, 3i Atlas has reached a brightness that puts it within reach of serious amateurs with telescopes in the 20 to 30 centimeter range and modern digital sensors. That is a simple, grounded fact. The same physics that allows a space agency to collect photons from it also allows a backyard observer, given dark skies and careful tracking, to gather enough light for a detailed, stacked image. When these observers process their data, they do not have to smooth it for a general audience. They do not need to protect anyone from complexity. They can afford to be curious. So they stack exposures, correct for motion, and let the noise sit a little closer to the surface, because buried inside that noise might be the first hints of structure that larger institutions have chosen not to highlight. In many of these unpolished frames, something interesting happens. Around the bright core of 3i Atlas, instead of a single symmetric haze, a more intricate pattern appears. A main tail stretches away from the sun, as expected, but there are also secondary plumes, fainter yet strangely sharp, peeling away at distinct angles. When these images are aligned and compared over several nights, those lesser tails do not wander randomly. They maintain their spacing like strands in a braided river, sometimes thickening, sometimes fading, but always echoing the same underlying geometry. To someone trained in comet physics, this can still be framed as jets from active regions on a rotating nucleus. To someone willing to sit with unease, it can also look like the signature of something rigid that is steering or modulating the outflow rather than simply being eroded by it. Here the notion of gatekeepers becomes tangible. Large agencies hold the keys to instruments in deep space and to telescopes that sit above most of the atmosphere. They decide which images are processed, which are released, which make their way into public briefings. Their duty is to provide accurate information, but they are also under constant pressure to maintain a sense of control and reassurance. When their staff prepare graphics for a high-profile event, they naturally select images that are clean, simple, and easy to explain in a few calm sentences. The more chaotic, high-contrast views, the ones where 3i Atlas looks less like a textbook example and more like a puzzle, are often left in technical repositories that few outside the field will ever explore. The night watchers have no such obligation. Their files are messy, their color balance is inconsistent, their tracking sometimes imperfect. Yet precisely because they do not answer to a narrative, they sometimes catch what the official record smooths away. A stack captured from a hillside in one country, combined with another taken from a coastal town thousands of kilometers away, begins to show the threefold nature of the tale in a way no single blurred press image ever did. On small online forums and quiet mailing lists, people circle those structures, compare orientations, and talk in the hushed, excited tone of those who sense that they may be looking at a story that has not yet been officially named. Grounded speculation grows naturally from this contrast. It is possible that space agencies simply regard these finer details as secondary, interesting for specialists, but not important for public consumption. After all, the average viewer needs to know only that 3I Atlas is not on a collision course, that it obeys gravity, that the sun will rise tomorrow, just as it did today. From that perspective, emphasizing the triple tail or the unusual steadiness of its geometry might only invite unnecessary anxiety or wild theories. Choosing safer, softer images then becomes a form of quiet risk management rather than an explicit attempt to deceive. At the same time, when the most striking features of an interstellar visitor are consistently omitted from mainstream coverage, the line between caution and concealment begins to blur. The imaginative leap, which we will entertain carefully, is this. Suppose that whatever lies inside the glowing skin of 3I Atlas understands the limits of our attention better than we do. Suppose it knows that only a thin scattering of dedicated individuals will ever stare long enough at unfiltered frames to notice patterns in the tail. From the perspective of such an object, large institutions that favor blurred composites and simple narratives would be a kind of accidental ally, amplifying only the safest aspects of its appearance, while the more revealing hints are left to circulate quietly in the shadows. In that scenario, the gatekeepers are not villains in a deliberate cover-up. They are simply playing their familiar role, keeping the broader public calm, while a deeper layer of the story unfolds just beyond the edge of official awareness. This leads to a question that may stay with you long after this video ends. In an age where both billion-dollar spacecraft and backyard telescopes observe the same sky, who will write the first honest portrait of an object like 3I Atlas? Will it come from a carefully sanctioned press release that shows only what fits an existing category, or from a sleepless watcher adjusting focus under a cold, clear sky, saving frame after imperfect frame, because something in their instincts will not let them look away? Somewhere between those two ways of seeing, a fuller truth waits, patient and quiet, for enough eyes to notice it at once. If you close your eyes for a moment and picture 3I Atlas not as a single still photograph, but as a series of nights stitched together, a more intricate shape begins to emerge. The main tail, streaming away from the sun, is the first thing you see, a familiar white river of dust pushed and curved by radiation. But then, as if your vision were slowly adjusting, two fainter streams separate themselves from that river. They peel off at steady angles, neither random nor symmetrical in a simple way, forming a triad that holds its geometry night after night. It is as though three ghostly fingers are being drawn through the darkness by an unseen hand, each leaving its own pale trace through the solar wind. In the language of comet science, none of this is impossible. A single nucleus can host multiple active regions, vents where sunlight warms buried ice and sends gas and dust jetting into space. As the nucleus rotates, these jets sweep around, sculpting the coma and tails into knots, fans, and spirals. Under the right conditions, discrete plumes can feed separate tail structures, especially if different particle sizes respond differently to sunlight and magnetic fields. That is the grounded, sober explanation, and it deserves to be heard clearly. Yet even within that framework, the specific behavior of 3I Atlas raises a quiet question. Why do these three streams maintain their spacing so consistently, like beams from carefully placed nozzles, instead of dissolving into a more chaotic spray as the object spins and moves? Observers who measure the angles between the three tails find that they do not wander wildly. One aligns roughly with the classic direction away from the sun, while the others fan out to the sides within a limited range, as if constrained by some deeper geometry. Over several nights, brightness may ebb and flow, but the basic pattern returns, echoing the same threefold structure. If 3I Atlas were simply shedding material from random fractures, we might expect more erratic behavior, bursts here and there, tails that split and recombine without any clear preference. Instead, the triple configuration feels oddly disciplined, as if there is a framework inside the coma that keeps channeling the outflow along preferred paths. This is still speculation, but it is speculation that grows naturally out of paying close attention to what the light is doing. Now the imaginative leap approaches, and we will let it settle gently rather than rush it. Suppose, for the sake of thought, that those three tails are not only the byproduct of outgassing, but also serve as a set of directed jets, a kind of crude propulsion or attitude control. In that picture, 3I Atlas is less a passive snowball and more a drifting machine that has wrapped itself in ice and dust. The triple tail becomes an arrangement of thrusters, firing in patterns that just happen to mimic the complex jets of a comet closely enough to keep most observers satisfied. When extra energy is available, from sunlight or from a passing solar storm, the tails brighten and shift in ways that maintain both navigation and disguise. The object moves through our system under a cloak woven from its own exhaust. Nothing in the images proves this is happening, but nothing in the basic physics of outgassing rules it out either. There is a subtle psychological layer here as well. A single tail is comfortable. It fits children's drawings and textbook diagrams. Even a double structure can be absorbed as a mix of dust and ion components, one curved, one straight. A persistent triple tail, however, unsettles that simplicity. It hints at a pattern, and patterns invite stories. To keep the public anchored in the safe mental image of a standard comet, you would be wise not to dwell on the third stream. You might mention it briefly as a curious but harmless feature, or you might choose images where it is washed out by exposure settings, leaving only the main plume clearly visible. In this way, the most suggestive aspect of 3I Atlas can be softened into the background, present for those who go looking, but easy to miss for everyone else. A more modest, grounded explanation still stands beside this conjecture. Different parts of a rotating nucleus receive sunlight in different ways, and the interplay between dust size, gas flow, and magnetic fields can naturally favor a few dominant directions for material to escape. In such a scenario, the triple tail is not a sign of intent, but a byproduct of a complicated, uneven surface being heated in a dynamic environment. The fact that this explanation exists is important. It keeps our feet on the floor even as our thoughts brush against the ceiling. Yet it is equally important to admit that at the level of the images themselves, both views can occupy the same data. A carefully engineered object could hide behind the same physics that describes an eroding one. The light does not tell us which story to prefer, it only shows us the shapes. As you picture those three pale rivers streaming from 3i Atlas into the dark, it might help to let both possibilities drift side by side in your mind. On one side, an icy shard from another star, cracked and venting along a few stubborn fissures, painting the sky with natural, if unusual, grace. On the other, a sleeper, wrapped in a self-generated fog, using controlled outflow to both move and mislead, letting the triple tail betray just a fraction of its internal design to those patient enough to measure it. The unsettling question that lingers is simple and deep. When we look at 3i Atlas and see those three streams, are we witnessing geology or choreography? In the next part of this dossier, we will listen more closely to a quiet remark from Avi Loeb about shells of ice and dust, and consider how his words might apply not only to the skin of 3i Atlas, but to whatever waits inside it. If you watched the November coverage closely, you might remember a quieter moment that did not come from a space agency studio at all, but from a different broadcast with a very different rhythm. A host leans forward, asking whether objects like 3i Atlas could ever be anything more than frozen debris. Avi Loeb, known for his willingness to entertain unpopular possibilities without raising his voice, answers with a simple, disarming image. Even a spacecraft, drifting through interstellar space for a long enough time, he says, would start to collect ice and dust. From a distance, under the right lighting, it could look very much like a comet. The remark passes quickly, the conversation moves on. Yet for those who have been staring at the softened images of 3i Atlas, that one sentence lands like a small stone in still water, sending slow ripples through everything they thought they were being told. There is nothing sensational in what he describes at first glance. Physics does not care whether an object began its life as a natural rock or a manufactured vehicle. If it is cold and exposed to gas and dust, those materials will settle, freeze, and accumulate. Over time, they can build a shell, an icy rind that hides whatever original shape lies beneath. This is a grounded, almost mundane idea. We already know that asteroids can borrow material from comets, and that comets themselves can evolve crusts of darkened, processed ice. Loeb is simply extending the same logic to any solid body wandering through space long enough. Yet because he attaches this image to the word spacecraft, he quietly shifts the frame. The listener is invited, if only for a second, to imagine that somewhere under a familiar glowing coma, there could be something that did not start as a chunk of frozen rock at all. Once you let that picture form, it becomes hard not to apply it back to 3i Atlas. The official story, repeated throughout the November 19th livestream, is that we are looking at a comet, an icy nucleus only a few kilometers across, wrapped in evaporating gas and dust that reflects sunlight and creates the tails. Loeb's remark does not contradict that. It adds a layer beneath it. Yes, he seems to say, it can be a comet on the outside and still be something else inside. The outer shell becomes a kind of clothing, a skin that tells a story designed for distant eyes. The inner core becomes something private, perhaps inert, perhaps not, moving through space under cover of a disguise that our instruments are all too ready to accept as natural. Suddenly, the phrase that officials keep using, just a comet, feels less like a conclusion and more like a description of the costume. Scientifically, the distinction between skin and core is not fantasy. When astronomers model comets, they often work with a layered structure. There is volatile material near the surface that responds quickly to sunlight, and there are deeper regions that may remain insulated and mysterious. Outgassing can seal over old vents and open new ones. Crusts can form and crack. A spacecraft like the Rosetta mission to Comet 67P saw cliffs, pits, and jets that hinted at complex internal architecture hidden beneath a dust-covered exterior. If time and conditions can carve such intricacy into a natural nucleus, it is not impossible that a non-natural object passing through multiple environments could end up wearing a shell that looks similar. The hard fact is that, from dozens of millions of kilometers away, our telescopes see only the outer behavior. They measure light from the skin, not the thoughts, if any, of the core. This is where grounded speculation about the institutional behavior begins. Imagine sitting inside an agency, watching public interest swirl around 3I Atlas. You have Loeb's remark circulating in the media, suggesting that, in principle, an artificial object could be cloaked in cometary ice. You also have your own internal assessments, which may include probabilities that are not comforting, scenarios that are not easy to explain. You cannot honestly rule out the possibility that the core of 3I Atlas is unusual, perhaps denser, perhaps more structured than a simple snowball. At the same time, you have a responsibility not to encourage panic or wild speculation. One way to thread that needle would be to anchor every public statement firmly to the outer shell. You speak only of the coma, the tails, the observed outgassing. You classify everything you show as consistent with a comet. You are not technically lying. You are simply declining to discuss anything that cannot be photographed directly. The imaginative leap arises when we consider Loeb's comment as more than a passing thought. Suppose he is not merely indulging a hypothetical, but offering a gentle warning in a form that can still be dismissed as metaphor. A spacecraft can wear a cometary mask, he says, and perhaps something out there already does. In this reading, his remark becomes a kind of key. It unlocks the idea that truth and concealment can coexist in the same sentence. Yes, the images of 3I Atlas show ice and dust. Yes, the spectra reveal gas that behaves like that of a typical comet. Yes, the coma and tails follow the sun. All of that can be honestly reported, while a deeper, more unsettling possibility remains unspoken. The shell can be completely real, entirely natural in its behavior, and still be hiding a core that was designed rather than formed. The institution preserves plausible deniability. The whistle of doubt is left for viewers to hear on other channels, in other interviews, while the main stage stays quiet. For those lying awake and thinking about this, an uncomfortable question begins to form. If the outer layer of 3I Atlas looks exactly as a natural comet should, how would we ever know if something else was riding inside it? Our instruments are tuned to see the skin. Our models are built on the assumption that the core is a simple extension of that skin inward. When someone like Loeb suggests that this assumption might not always hold, he does not give us a new instrument. He gives us a new way to read our own discomfort. Perhaps that is why his sentence about spacecraft and cometary shells lingers. It is not because it proves anything about 3I Atlas, but because it names the very gap that a careful institutional narrative can exploit. What you see is true, it says. It is just not the whole of the truth. As we leave this strand of the dossier, hold that duality in your mind: a shell that is honestly described and a core that is politely ignored. A scientist who speaks softly about how machines can wear ice, and agencies that speak confidently about how comets behave. Between these two voices, 3i Atlas glides on, wrapped in its luminous skin. In the next section, we will watch what happens when a storm from the sun collides with that skin and fails to tear it away, and we will ask whether the way 3i Atlas absorbs that blow tells us anything more about what might be hidden at its heart. On some level, every bright object in the sky is also a kind of clock. Stars flare and cool, planets spin, and the sun itself breathes in long, slow cycles that send invisible storms through the solar system. By late November, anyone who follows space weather had already seen the warnings. A region on the sun had erupted, throwing a coronal mass ejection out into space, a great billowing cloud of magnetized plasma expanding like a slow-motion wave. Forecast models showed it racing along a path that would wash through the same sector where 3i Atlas was moving, a few days after the reassuring words of the 19th had faded from people's screens. While most viewers turned back to their daily lives, a handful of listeners kept one eye on the sun and one eye on this interstellar visitor, waiting to see what would happen when the storm and the stranger met. A coronal mass ejection is not just a poetic phrase. It is a real, measurable event, a pulse of charged particles and tangled magnetic fields launched from the outer atmosphere of the sun. When one of these waves sweeps across an Earth, it can disturb our planet's own magnetic shield, bending and shaking it, triggering auroras and, in stronger cases, rattling power grids and radio links. When it crosses the path of a comet, the effect is even more intimate. The solar wind that calmly shapes a tail on most days becomes a sudden gust that can seize that tail like a loose ribbon and tear it away, leaving the nucleus briefly naked before a new plume slowly regrows. That tearing is called a disconnection event, and it has been documented in several comets, a natural response written into the quiet physics of dust, gas, and magnetism. By the time the live stream about 3i Atlas aired on November 19th, the solar eruption that would cause the late-month storm was already on the books. Solar observatories had traced its origin, measured its speed, and issued routine bulletins predicting when its front would reach the region near Earth's orbit. None of this was secret. Space weather centers released diagrams showing the expanding bubble sweeping past our planet, and with a little careful reading, you could see that the same bubble was likely to brush the part of space where 3i Atlas was then traveling. For those who think in orbits and timelines, it was hard not to notice the convergence. Within a few days of the official reassurance that this was an ordinary comet, nature was about to provide an unusually powerful way to test that story. A genuine storm would strike the glowing skin of 3i Atlas and write its own verdict in the behavior of the tails. Here is where the silence becomes harder to ignore. During the broadcast, speakers mentioned many things: the interstellar origin of 3i Atlas, the opportunities it provided to understand how such objects behave, the beauty of its luminous envelope. What they did not mention, even in passing, was that a significant coronal mass ejection was en route to the very region of space where this object was wandering. There was no discussion of what a strong solar storm can do to a comet's tail, no gentle promise to share follow-up results after the wave had passed. To a casual listener, this omission means nothing. The words comet and interstellar are already enough to fill the imagination. But to someone who knows that comets have literally lost tails in such encounters before, the absence of any reference to the impending starmusome feels almost deliberate, like editing out the most interesting page from a story just before you hand it to the reader. Scientifically, there was every reason to treat the storm as part of the unfolding experiment. If 3i Atlas were truly just an ordinary icy body from another star, then watching how its triple tail responded to a sudden blast of solar plasma would be invaluable. Would one of the tails disconnect cleanly, or would all three snap and reform? Would the coma brighten or dim? How would the object's interaction with the magnetic field compare to what has been recorded for familiar comets inside our system? Each of these questions could, in principle, be answered with honest observations before and after the storm. The data would either reinforce the comfortable narrative or gently challenge it. Either way, the public could be invited along for the ride, seeing in real time how nature stress tests a visitor from deep space. Grounded speculation begins when we ask why such a straightforward opportunity received so little attention in the official script. One possibility is simple caution. Space weather forecasts carry uncertainties, and no one wanted to promise an interaction that might turn out to be weaker or more distant than expected. Another is narrative discipline. The November 19th briefing was built around closure, around the mantra that 3i Atlas fits neatly into known categories. Introducing an unscripted solar storm into that story would open doors again, invite fresh questions, drag the object back into the realm of the unresolved. For institutions that prize stability, there is a strong temptation to leave those doors closed, to quietly ignore variables that lie outside the comfortable arc of the presentation. The imaginative leap extends that line of thought one step further. Suppose that internally, analysts had already modeled the likely interaction between the storm and 3i Atlas and found that it might not behave quite as tamely as the word comet suggests. Perhaps simulations hinted that its tails would resist disconnection, or that its coma would respond in a way that would be difficult to explain without invoking unusual density or magnetic properties. In that case, the approaching coronal mass ejection would not just be an interesting side note, it would be a potential embarrassment, a natural experiment that might force revisions to the reassuring story that had just been told on camera. Under those conditions, choosing not to mention the storm at all becomes a way of reducing the number of eyes that will be watching critically when it arrives. There is also a more unsettling, almost whispered possibility that belongs squarely in the realm of thought experiment. What if the storm was not merely a threat to 3i Atlas, but an opportunity for it? In our own technology, we already dream of spacecraft that can harvest an energy from changing magnetic fields, that can ride plasma waves the way a surfer rides ocean swells. If something inside 3i Atlas were capable of doing anything similar, a coronal mass ejection would be less a hazard and more a gift, a dense, moving reservoir of energy sweeping across its path. In that picture, the silence of the institutions takes on an eerie resonance. A storm is coming, one that could act as a kind of charger for a cloaked machine, and those who might be in the best position to observe it choose not to draw attention to the event. As you lie there listening, this chain of possibilities does not need to solidify into certainty. It is enough to let the pattern trace itself across your thoughts. a predicted solar storm, a known tendency for such storms to rip tails from comets, a once-in-a-generation interstellar visitor sitting in the path of that wave, an official briefing that never mentions any of it. Between these points, your mind will naturally draw lines, some cautious, some darker. In the next part of this dossier, we will look more closely at what actually happened to the visible structure of 3I Atlas as the storm passed, and ask whether its composure under pressure tells us something quiet and unsettling about the strength of whatever may lie at its core. When the storm from the sun finally reached the region of space where 3I Atlas was drifting, there was no sound, no visible shock front, just a gradual thickening of the invisible wind. Charged particles that had been moving in smooth, quiet streams were suddenly tangled into a denser, more agitated flow. To a comet, this kind of change is usually written in the language of loss. The classic examples are there in the archives, sequences where a bright tail is cleanly severed, kinked and pushed aside as the solar magnetic field snaps and reconnects. For comets like Encke and others that have wandered close to the sun during active years, a strong coronal mass ejection has meant a brief, spectacular undoing, a moment when the graceful plume that had been growing for weeks is torn away and left trailing behind like a discarded veil. In those records, you can see the principle as clearly as a diagram. When the storm arrives, the tail breaks. The nucleus carries on, but the flowing hair it has grown is vulnerable, a temporary structure at the mercy of the sun's changing mood. Those who watched 3I Atlas through the late November storm expected something similar. The physics should have been the same. A triple tail is still made of dust and ionized gas, still guided by the same interplay of sunlight and magnetic fields. If anything, its complex structure should have made it more susceptible to disruption. 3 separate streams mean 3 chances for disconnection, 3 opportunities for kinks and gaps to appear as the storm front passed. Quietly, without much fanfare, a handful of observatories turned their instruments toward the visitor during and after the predicted arrival time. Amateur telescopes followed suit where skies and time zones allowed, their operators knowing that even a modest aperture can catch the broad strokes of a disconnection event. The question was simple and empirical. Would the triple tail of 3I Atlas snap, or would it hold? The answer, written in frame after patient frame, was unsettling in its calm. There were changes, of course. Brightness wavered, subtle ripples crept along the tails, as if the entire structure had shivered under a passing hand. A faint kink here, a temporary dimming there, hinting that the storm really had swept through, but the fundamental geometry remained intact. No clean severing, no obvious disconnection event, no dramatic scene where the tails broke away en masse and floated off as the nucleus forged ahead. Instead, 3I Atlas seemed to absorb the gust. Its threefold plume bent and flexed and then, within the limits of our instruments, resumed its prior configuration, like a banner that has snapped in the wind but refused to tear. For those who had expected textbook behavior, this resilience was a surprise sharp enough to feel like a small betrayal. Nature, when behaving strictly by the book, is not usually this accommodating. There are grounded ways to soften that feeling. Not every coronal mass ejection is equally strong at every point in space. Magnetic field lines can drape and diverge, leaving some objects in a relative shadow of disturbance, even as nearby regions are hit harder. The angle between the storm front and the path of 3I Atlas may have been such that the most intense effects skimmed past, weakening the tug on its tails. It is also possible that the timing of the observations missed a brief, partial disconnection, that a gap opened and reformed in a window when no one was looking, hidden in those unrecorded hours when telescopes had to yield to daylight and weather. These are real, sober possibilities, and any honest analysis has to lay them on the table. The fact remains, however, that in the data we do have, the triple tail of 3I Atlas behaves less like a fragile appendage and more like something with an underlying spine. Here the imaginative leap offers a darker mirror. If the tails of 3I Atlas are not merely byproducts of sublimation, but are guided by a structure inside the coma, then a solar storm striking them would be more like wind hitting the rigging of a ship than like gusts tearing at loose smoke. Rigging can strain, creak, and yet hold because it is anchored to something solid that can redistribute the force. In this picture, the magnetic and plasma environment around 3I Atlas is not a passive victim of the coronal mass ejection, but an active system that can adjust, reconfigure currents, and keep the overall pattern coherent. The storm becomes not a threat of amputation, but a stress test, one that the hidden framework passes with quiet confidence. The triple tail bends because it must answer to the sun, yet it does not break because it also answers to something else. As you let that possibility sit beside the official story, a more subtle unease may surface. If an object from interstellar space can ride out a significant solar storm without shedding its most delicate-looking features, then our categories for comets, asteroids, and visitors from beyond may be less complete than we have assumed. We are used to thinking of these bodies as fragile, transient things, sculptures of ice and dust that the sun can easily reshape. Watching 3I Atlas hold its form under pressure suggests either that we have encountered an unusually robust specimen or that robustness itself is a clue. The open question that lingers is simple and quietly troubling. Did the tails of 3I Atlas survive the storm because we caught a lucky combination of geometry and timing, or because something inside that glowing skin was never as vulnerable as we were led to believe? If storms cannot easily strip that skin away, then how many more chances will we have to see what, if anything, is truly moving beneath it? The storm from the sun does not only bring chaos, it also brings structure folded into the invisible lines of its magnetic field. To most comets, that structure is a force that tears, pulling tails apart and scattering their dust into new, thinner veils. But once you have seen how stubbornly the triple tail of 3I Atlas held its shape during the late November disturbance, another thought begins to form at the edge of awareness. What if the storm was not just a test of fragility, but a delivery of something that 3I Atlas could actually use? What if the space through which it drifted on those days briefly turned into a kind of power socket, and the object, wrapped in its luminous skin, was quietly ready for the plug? To entertain that thought, we have to sit for a moment with how charged particles and magnetic fields behave. In plasma physics, changing magnetic fields can induce currents. Conductive structures moving through magnetized flows can set up electrical potentials, siphoning energy from motion into ordered charge. The same basic principle that makes a generator work in a power plant also operates in a more diffuse way in space. Moons moving through the magnetic fields of giant planets can trail invisible electrical wakes. Spacecraft passing through regions of dense plasma must be carefully designed so that stray currents do not build up across their surfaces. The environment that surrounded 3I Atlas during the passage of the coronal mass ejection was not a featureless wind. It was a textured sea of charged particles and shifting fields, rich with the very ingredients our own engineers dream of harvesting one day to power long-duration missions between the stars. From the perspective of an ordinary comet, all of this is just weather. The nucleus has no circuitry, no intentional structure. It is a porous mix of ice and rock that simply charges and discharges along whatever paths the material affords. Surface regions facing the storm may develop temporary electric fields. Dust grains are tugged and sorted by their charge to mass ratios. The result is motion that looks complex but is fundamentally passive. The comet is being played upon by the environment, not playing along with it. From the perspective of a hypothetical object with internal conductors and an ability to shape its own coma, however, the storm becomes an opportunity. The tails themselves could act as extended collection structures, long filaments of ionized gas reaching into the flow, channeling charge back toward regions where fields have been quietly arranged to receive it. There are scientifically grounded hints that this kind of interaction is not pure fantasy. Space physicists study structures called Alfvén wings, where a conducting body in a plasma flow creates standing magnetic patterns that can link back to a source. Observations of moons like Io show that its motion through Jupiter's magnetosphere generates electrical currents that travel along field lines and deposit energy elsewhere in the system. If an object inside the coma of 3I Atlas possessed even a modest ability to guide charges, the passage of a dense solar storm could set up similar currents on a smaller scale. The triple tail, in that scenario, is not only a byproduct of sublimation, but also a set of shaped conduits, each sampling a slightly different slice of the plasma flow and feeding it back into an unseen architecture beneath the ice. Now, the imaginative leap steps closer. Picture 3I Atlas gliding through the thickened solar wind as the front of the coronal mass ejection arrives. The brightness of the tails increases, not chaotically, but in a way that seems to breathe in time with the passage of the storm. There is no explosive break, no dramatic shedding. Instead, the object appears to swell with a kind of quiet intensity, as if the added energy is being taken in, distributed, and then released in more controlled streams. In the days that follow, small changes in trajectory or outgassing might be subtle enough to hide inside the uncertainties of our measurements, yet significant enough from the object's own point of view to count as a course correction or a spin adjustment made possible by the storm's gift. In this view, the sun is not merely sculpting 3I Atlas. It is, for a brief window, refueling it. Of course, such a picture sits far beyond what we can claim as fact. It asks us to imagine a level of design and patience that, if real, would alter our place in the cosmic story. That is why it is important to keep the more modest interpretation in sight at the same time. Perhaps the resilience of the tails was simply the result of a less intense region of the storm passing over 3I Atlas. Perhaps the timing and angle were such that the strongest fields never fully engaged with the coma. Perhaps our sampling of the object's behavior before and after was too sparse to catch the more fragile details of its response. In that light, there is nothing to see but an interstellar comet that endured a solar gust with little drama, a curiosity, but not a revolution. Yet even if we lean on that modest view, a question remains that is harder to file away. Why, given the known power of such storms to reveal the structure of a comet, was so little made of this particular encounter in official narratives? If you are confident that 3I Atlas is nothing more than ice and dust, then a coronal mass ejection crossing its path is a perfect chance to demonstrate that confidence, to show the public how prediction and observation align. When that chance is passed over in silence, the space left behind fills naturally with speculation. It is in that space that notions like the charging station hypothesis take root, not as declarations, but as responses to an absence of explanation. Lying awake, you do not have to decide which picture to believe. You can let them coexist in layers. On the surface, a comet passes through a solar storm, its tails flickering but intact. Beneath that, the quiet possibility that something inside 3I Atlas knew how to drink from the turbulence, turning a passing wave into stored potential. The unsettling part is not that we lack the instruments to know which layer is true. It is that those who might be closest to the full data seem strangely uninterested in asking the question out loud. If the space between the Sun and 3I Atlas briefly became a corridor of power, we are left wondering who or what walked down that corridor and whether it emerged on the other side just a little more awake than before. For a long time now, the story of 3I Atlas has circled around its surface, its tails, and its strange poise in the face of a solar storm. But if you let your mind fall slowly inward, past the glowing skin and the triple plume, an older question is waiting like a stone at the bottom of a well. What exactly is the core of this object? Is it the fossil heart of a broken world, worn down by eons between the stars? Or is it something more deliberate, a sleeping machine that has learned to wear a comet's face? Between those two images stretches almost everything we fear and hope about what might drift in the dark beyond our sun. When astronomers speak of cores, they often think in planetary terms. Inside rocky worlds, heavy elements sink and separate, forming dense centers wrapped in layers of lighter rock and volatile shells. When such worlds are shattered by impacts or torn by gravitational tides, fragments can be launched into new orbits, some of them flung completely free of their home systems. Over millions or billions of years, those fragments cool, darken, and forget their origins. A shard of an iron core or a piece of an ancient mantle could wander interstellar space until chance brings it into another star's domain. Seen from afar, with a cloak of acquired ice and dust, such a relic would look like what we call an interstellar comet. Yet its true density and strength would be far beyond that of a fragile snowball. There are hints, even in our own system, that such compact survivors exist. Some asteroids have densities so high that only a mostly metallic composition makes sense. Others rotate so quickly that a loose rubble pile would fly apart, which means they must be held together by deeper cohesion. If 3I Atlas carries a core like that, a fossil from some long-dead planet, it would explain at least part of its behavior. A dense, cohesive heart could shrug off tidal stresses, maintain its spin despite uneven jets, and anchor the triple tail with a steadiness that a softer nucleus could not. In this view, the resilience of the tails and the refusal to show a clean disconnection during the solar storm are clues pointing back to sheer physical toughness, rather than anything more exotic. Grounded speculation extends that picture. A planetary fragment that has spent ages in interstellar space would have had time to collect and lose multiple shells of material. Passing through different clouds of gas and dust, it could accrete fresh layers, then heat up and shed them over and over, like a stone being wrapped and unwrapped in frost each time seasons change. By the time it reached our sun, its surface might be a palimpsest of old scars and new coatings, a mix of native minerals and borrowed ice. The current coma of 3I Atlas could be just the latest expression of that long history, a temporary halo fed by a thin, volatile veneer over a core that remembers entire star systems we will never see. In that sense, to call it a comet is not exactly wrong. It is simply incomplete, a name for the latest mask worn by something with a far more complicated past. The other possibility, the one that moves more carefully along the edge of our comfort, is that 3I Atlas is not a fossil at all, but a device. Not a sleek silver craft from our stories, but a heavy, patient machine designed from the beginning to survive what interstellar space can do. If you were to design such a thing, you would likely start with a compact core, rich in dense metals and long-lived power sources, wrapped in layers meant to absorb dust impacts and cosmic rays. You might give it magnetic structures to shape and manage any plasma around it, and surfaces designed to hold or shed ice, depending on local conditions. After a few million years drifting between stars, even the most artificial outline would be rounded and softened by accumulated debris. By the time it entered a new system, it would already look halfway like a comet, needing only a little heating and a few well-timed jets to complete the disguise. Here the imaginative leap takes a more defined shape. Imagine that inside 3I Atlas there is a core not much larger than a small mountain, built rather than born, surrounded by reservoirs of frozen volatiles arranged intentionally. As it approaches a star, sensors wake and begin to bleed gas from selected vents, sculpting a coma and tails that mimic the statistical expectations of natural comets while still allowing subtle control over trajectory and spin. The triple tail we see would then be the outward sign of internal geometry. 3 main channels, 3 preferred axes along which material is released, 3 handles by which the object can push against the thin pressure of light and plasma. The late November storm from the sun in this story was not an accident endured by a passive body, but a known environmental phase built into the design, an expected surge of energy to be managed, harvested, and perhaps even awaited. There are, of course, hard facts that keep this picture tethered to reality, even as it stretches. The measured path of 3I Atlas through our system is open, a hyperbolic track that will carry it back out into interstellar space after its swing around the sun. Its speed and direction can be described entirely by gravity and the small forces of outgassing. No one has yet seen it execute a sharp, unexplainable turn. Spectra of its coma reveal common gases and dust consistent with other comets. Nothing in those measurements screams artificial alloy or exotic emission. If there is a machine inside, it is one that has learned to wear ordinary materials almost perfectly, to speak in the language of ice and rock so fluently that even detailed instruments hear only a familiar accent. Yet that, too, is part of what makes the idea so persistent. A planetary fossil and a sleeping machine can cast the same shadow, trace the same path, and glow with the same light if both are wrapped in the same kind of shell. Our telescopes see brightness profiles, velocities, and spectra. They do not see intent. When Avi Loeb speaks of spacecraft gathering ice and dust until they resemble comets, he is not claiming that any specific object, including 3I Atlas, is such a craft. He is reminding us that nature and technology can converge in appearance when exposed to the same environment for long enough. A machine that has drifted for ages between stars would, by necessity, look almost indistinguishable from a relic of natural violence. Both would be compact, durable, and wrapped in whatever material the cosmos has thrown at them. Somewhere between these two possibilities lies a quieter third. Perhaps the core of 3I Atlas began as a fragment of a world, but was later altered by intelligence, mined or engineered into a vehicle long after its parent planet died. In that hybrid picture, the object is both fossil and machine, a piece of geology repurposed into a tool for crossing gulfs that would defeat any fragile craft we can imagine. The dense core would carry memory in more than one sense, remembering impacts and tides in its structure, remembering instructions and designs in whatever systems have been carved or embedded within it. Its current passage through our system would then be just one chapter in a biography that started in the crust of another sun. As you hold these images in your mind, the unsettling question that lingers is not which one is true, but whether our current instruments and institutions are even willing to ask. If the core of 3I Atlas is a planetary fossil, studying it could teach us about worlds beyond our reach. If it is a sleeping machine, acknowledging that possibility would rewrite our place in the universe. Both outcomes are profound, yet the public narrative seems content to stop at the surface, at the skin of gas and dust that tells the simplest story. Deep inside that luminous shell, something heavy and silent is moving through the light of our sun. We may never know whether it is the broken heart of a lost planet or the armored hull of a patient device, but the way we choose to frame that ignorance will say a great deal about how ready we are to share our night with whatever else might be passing through it. The easiest way to disappear in space is not to be small, but to look boring. Telescopes survey the sky in wide, systematic sweeps, and software combs through those images looking for points of light that move, brighten, or behave in unusual ways. These systems are powerful, but they are tuned to a set of expectations. They know how comets are supposed to grow tails as they fall toward the sun. They know how asteroids are supposed to creep across the starfield from night to night. When something fits those patterns, it is cataloged and left to specialists. Only when an object refuses to follow the script does it rise into headlines and press conferences. In that sense, the safest camouflage for anything drifting into our system is not invisibility, but conformity. If you can stay just inside the lines of what normal looks like, you can move through a bright, watched universe and still remain effectively unseen. 3I Atlas, on the surface, seems to understand this. Its brightness rises roughly as models predict when a dusty body approaches the sun. Its color, a faint greenish tint from common gases, matches what many comets display. Its orbit is hyperbolic, as you might expect from an interstellar visitor falling in once and never returning. Its tails point away from the sun in a way that pleases both diagrams and classroom explanations. If you take each of these facts in isolation, there is nothing to see but an unremarkable interstellar comet following the rules. The strangeness only emerges when you begin to notice where it behaves just a little too well, as if it has studied our expectations and chosen to err on the side of being forgettable. To understand how an object could hide in plain starlight, it helps to think about how our surveys actually see. Most wide-field instruments do not linger. They take exposures measured in tens of seconds, then move on, building up catalogs of transient points. Automated routines subtract one night's image from another, flagging anything that shifts or flares. In this fast, subtractive world, detail inside a bright blur is almost irrelevant. What matters is the overall brightness, the centroid position, the way the light curve changes over days and weeks. If the skin of 3i Atlas is adjusted so that those broad quantities stay comfortably inside expected ranges, then the deeper structure of its core and tails can be as complex as it likes without sounding an alarm. The camouflage is statistical rather than visual. It hides in the averages. Grounded speculation starts with the simplest controls. A dense core wrapped in volatiles can, in principle, regulate how much gas it releases by exposing or shadowing active regions. Slight shifts in spin, tiny changes in the orientation of vents, could brighten or dim the coma by just enough to keep its light curve near the center of a predicted band. In practice, our models of comet activity are flexible. When an object is a little brighter or dimmer than expected, parameters are adjusted. Surface area, albedo, dust to gas ratio, all of these can be tweaked until the curve fits. As long as 3i Atlas keeps its behavior within those adjustable bounds, the story remains stable. It is easier to bend the model than to question the assumption that the object is fundamentally simple. There is also the geometry of glare. Many of the most sensitive observations of 3i Atlas happen when it is low in the sky before dawn or after twilight, or when it lies close to the sun's position as seen from Earth. In those conditions, scattered light from the atmosphere, optical ghosts and telescopes, and the sheer brightness of the sky itself conspire to blur away fine structure. An object that wished to keep its more revealing behavior private could take advantage of such alignments, timing bursts of activity or subtle maneuvers for moments when observers must peer through thicker air or closer to the halo of the sun. From our point of view, small asymmetries in the coma would simply drown in the glow. From its point of view, the brightest lamp in the system doubles as a curtain. Historically, we have already seen how easy it is to miss important structure when an object shares the sky with something more obvious. Meteor showers arrive and draw the eye downward, even as their parent streams record deeper patterns in the orbits of comets. Solar flares captivate with their looping arcs on the sun's surface, while the slower, wider coronal mass ejections that follow receive less attention from the general public. A visitor like 3i Atlas can slip between such spectacles, never being the brightest or nearest event on any given day, always framed as a supporting character in a larger show. It is only when you thread all the data together from different instruments and different weeks that you see how consistently it has stayed inside that safe zone of relative unimportance. The imaginative leap asks what this would look like if it were not an accident. Picture a core inside 3i Atlas, equipped with instruments of its own, able to read the density of the solar wind, the angles of incoming light, the distribution of telescopes pointed its way. With that information, it could treat our gaze as just another environmental factor to navigate. When a major observatory schedules deep imaging at a certain time, the object might respond with slightly reduced outgassing, smoothing features that would otherwise stand out. When attention drifts elsewhere, it might allow more pronounced jets or internal adjustments, knowing that the resulting irregularities will be noticed only by a few insomniacs comparing frames on quiet nights. In this scenario, the skin of gas and dust is not just a byproduct. It is a responsive interface tuned to the rhythms of both the sun and our surveillance. Even without assuming anything that deliberate, there is a quieter way in which 3i Atlas can hide in plain sight. Our classification systems are built from stories we have already told ourselves. The category interstellar comet did not exist in a practical sense until the first objects of that type were discovered. Once the label was created, anything that roughly fit the criteria could be placed there, its oddities smoothed out by the comfort of having a box to live in. 3i Atlas arrives after that box has already been built. The language to describe it, the comparisons to earlier visitors, are ready on the shelf. Calling it the next example in a short list makes it feel less like an intruder and more like a data point in a growing curve. The very act of naming becomes a kind of covering. There is one more layer to this camouflage, and it does not come from nature at all. It comes from boredom. Public attention, like survey software, is tuned to spikes and anomalies. A dramatic trajectory change, a sudden unexplained flare, a catastrophic breakup, these would all seize the collective imagination. A slow, steady glow that behaves just close enough to predictions quickly becomes background. Official narratives that repeat the same reassurances feed this drift toward disinterest. Each time a spokesperson says there is nothing unusual to worry about, a few more people turn away, trusting that someone else will watch for them. In that thinning gaze, 3i Atlas, whatever it truly is, finds the deepest shadow of all. As you think about this, an unsettling question takes shape. If an object can manage its skin, its timing, and its behavior so that it always appears ordinary to systems that are already inclined to smooth away complexity, how would we ever notice that something more is happening inside? Would it require a blatant mistake on its part, a flare fired at the wrong moment, a tail that bends when it should break? Or would it take a new way of watching, one that is less impressed by averages and more attentive to the quiet persistence of small, strange details? In the next part of this dossier, we will look at those details in time rather than in space, asking whether subtle shifts in the rhythm of 3i Atlas after the late November storm might be read, not just as weather, but as the faint outline of a reply. In the days after the storm, the light from 3i Atlas settled into a new kind of restlessness. To the naked eye in a telescope, it was as gentle as ever, a pale smudge with a soft core and that persistent triple tail. But on screens in darkened rooms, where its brightness had been turned into numbers, a different picture began to flicker. Points on graphs that had once risen and fallen in a smooth, predictable rhythm started to show small hesitations, tiny extra steps in their dance. A dip arrived a little earlier than expected. A peak stretched slightly longer before falling. To most observers, these shifts lived well inside the noise, too subtle to disturb the sleep of anyone who trusted the averages. To the few who had been watching 3i Atlas as closely as others watch a heartbeat, the pattern felt less like random jitter and more like the first uncertain syllables of a reply. Photometry is a quiet science. Night after night, instruments measure the brightness of a target, correct for the atmosphere, subtract the background, and reduce the sky to a stream of values. Comets are allowed to be moody. They flare when fresh ice is exposed, dim when jets turn away, spike when fragments break free. Their light curves look messy, but the mess is usually uncorrelated, a scribble with no clear rhythm beyond the slow pulse of rotation. When researchers ran the post-storm data of 3I Atlas through period-finding algorithms, the expected rotation signatures appeared, hints of a slow spin modulating its glow. Yet superimposed on that, faint but persistent, were bumps that seemed to cluster at nearly regular intervals, as if some process were turning on and off in a cadence not entirely explained by sunlight and spin. It could be nothing. It could be everything. On the graphs, the difference between those two possibilities was only a few tenths of a magnitude, small rises shaped like footsteps seen through fog. Grounded explanations came first, as they should. The coronal mass ejection that had passed through the region had disturbed the solar wind for days, creating ragged variations in the pressure washing over 3I Atlas. Slight changes in that pressure could easily modulate the tails in coma, brightening and dimming them in a pattern that reflected the complex structure of the passing plasma. Dust grains of different sizes respond differently to these changing flows, and their combined behavior can produce beats and echoes in the light curve. In that view, the post-storm flicker was simply the comet's skin ringing like a bell after being struck, natural harmonics vibrating themselves out. Another possibility was geometric. As 3I Atlas moved along its path, the angle between its triple tail and our line of sight shifted, changing how much light each plume contributed to what we saw. Combined with rotation, this could easily generate quasi-regular brightening as different jets swung into a more favorable orientation. None of these ideas require anything artificial. They are the kinds of stories scientists tell each other to tame restless data. Yet for those already unsettled by how stubbornly the triple tail of 3I Atlas had survived the storm, another thought would not quite leave. What if the flicker was not only the fading ring of a bell, but also a carefully timed tap on the glass? In other words, what if the object had used the storm not just to endure and perhaps to absorb energy, but also to send something back? In a vacuum where radio waves and particles serve as messengers, a crude form of signaling could, in principle, be built from precisely the tools a comet already seems to have. By modulating the rate at which gas is released, by shaping the density of the ionized tail, and an internal system could slightly nudge the way 3I Atlas interacts with the solar wind. Those nudges, repeated with regular spacing, would appear at a distance as tiny, periodic changes in brightness or tail structure, faint pulses written into the glow. Nothing in our data processing is tuned to see that as a message. It would register only as another small, stubborn anomaly queued for later. There are other channels besides light. Around the time of the storm, radio observatories listening to the sun and the wider sky recorded their own surges and crackles. Spacecraft scattered through the inner system sent back plasma and field measurements that mission teams carefully logged. In those records, any brief, narrow band disturbance coming from near the direction of 3I Atlas would have had to compete with the roar of the sun itself, with bursts of interference from Earth and with the steady chatter of our own machines. Engineers are trained to label unexplained blips as instrumental glitches, to clear them from the slate so that planned signals and known natural emissions stand out more clearly. It is entirely possible that on some screen during those days, a faint, oddly timed spike appeared from the region where 3i Atlas was gliding, only to be dismissed as noise in a stormy sky. The imaginative leap asks us to look at that dismissal from the other side. Suppose, for a moment, that something within 3i Atlas did attempt a crude reply after the storm, using its newly charged environment as a carrier. It would not need to speak in narrow beams or complex codes. To an intelligence that expects no one to be listening, any signal at all is an extravagance. A simple pattern would do, a repetition of pulses spaced by a constant interval, a series of controlled brightenings or density changes in the tail, perhaps accompanied by a modest radio modulation riding on the disturbed solar wind. From its perspective, this would be like knocking softly on a door in a house you suspect is empty. From ours, buried in the static of the sun and the blind spots of our curiosity, it would be nothing more than a few strange data points in a file labeled miscellaneous. The idea does not claim that such a signal was sent. It only points out how alarmingly easy it would be for us to miss it if it were. Even without invoking intent, there is a quieter way to think of these post-storm quirks as a kind of echo. Any system with internal structure will ring differently when struck than a formless cloud. The way 3i Atlas settled after the storm, the way its triple tail and coma returned to their prior outline while carrying small recurring ripples, is, in itself, a kind of reply to the sun. It is a statement about internal stiffness, about how firmly the skin is anchored to whatever lies beneath. Our instruments translate that statement into small numbers, our models translate it into adjusted parameters, and then, in many cases, the story stops. The echo is recorded, but not interpreted. It becomes part of a growing archive of objects that almost behaved exactly as we expected. There is a human echo here as well. People who watched the data closely during those days and noticed something odd are left in a peculiar position. They can write cautious papers that frame the anomalies as interesting, but probably natural. They can whisper to friends about how much the curves look like a pattern. They can do both, living in the tension between professional restraint and private wonder. Institutions, for their part, rarely call attention to such liminal findings. It is easier to wait for something undeniably dramatic than to stand before the public and say that an interstellar visitor might have twitched in a way that is suggestive, but not conclusive. Silence, once again, fills the space where a more daring imagination could have been invited in. As this section of our dossier draws to a close, you are left holding an image that is more feeling than fact. A storm has passed. An object from another star has flexed under the blow and then settled, its light still flickering in small, stubborn patterns that our instruments dutifully record and our narratives politely overlook. On one level, 3i Atlas remains exactly what the official voices say it is, a comet wrapped in its own evaporating skin, traveling along a calculated path that will soon carry it away. On another level, it is a question that has been asked and not yet answered, a presence that may or may not have used a brief window of energy to whisper something into a noisy universe. In the next part of this story, we will step back from the core and the storm and look toward the date when 3i Atlas will be closest to us, asking how human institutions have responded to that approaching moment and what it means that while some eyes close, Others remain quietly fixed on a point of light that may already be leaving us behind. By the time the calendar had slipped a week or two past November 19th, the world's attention had already flowed on to other things. The thumbnail of the 3i Atlas livestream sank lower on video pages, replaced by new launches, new crises, new entertainments. For most people, the memory of that soft-spoken event compressed itself into a vague impression. Something about an interstellar comet, something about everything being fine. The details of pixel scales, tail geometry, and solar storms dissolved into the background hum of half-remembered science. The official recording remained online, of course, perfectly preserved, but it may as well have been frozen in amber. Its primary task had been completed in the first few hours, when it took a restless question and wrapped it in a tone of gentle closure. After that, the main work of shaping perception passed not to telescopes or laboratories, but to algorithmic feeds that quietly buried 3i Atlas under fresher distractions. Inside institutions, the aftermath looked different. Reports continued to circulate, full of numbers, plots, and cautious phrases. Teams that tracked interstellar objects, refined orbital elements, compared 3i Atlas to earlier visitors, and slotted it into growing tables of parameters. Space weather groups logged the passage of the late November storm and filed its effects under routine events. In internal meetings, scientists may have raised questions about the resilience of the triple tail, about the odd stability of the coma, about small irregularities in post-storm light curves. But when it came time to translate all of that into public communication, the same thin vocabulary resurfaced. The object was a comet. Its behavior was consistent. There was nothing to worry about. In press releases and interviews, these phrases appeared again like a mantra, smoothing over every rough edge with the reassurance that what had been briefly unusual was now comfortably understood. Grounded speculation about this pattern does not require secret orders or hidden counsels. Large agencies operate under constant pressure to maintain trust. A frightened public becomes unpredictable. An anxious media environment amplifies rumors and conspiracy theories that can harm real missions and lives. When something like 3i Atlas captures attention, communication teams are tasked not only with sharing information, but with managing emotional response. They know that words like anomaly and unknown can set imaginations alight in ways that are hard to control. They also know that their reputation depends on appearing calm and in command. Under those conditions, the safest path often lies in overcorrecting toward boredom, in presenting even genuinely interesting puzzles in a tone that lulls rather than excites. Not because the scientists themselves are bored, but because they are aware of the cost of lighting fires they may not be able to put out. So a strategy unfolds that is rarely named. You acknowledge just enough curiosity to seem honest, but not enough to spark fresh waves of attention. You schedule no grand follow-up event around the late November storm or the coming closest approach in December. You release data in small, technical batches rather than in dramatic visual packages. When asked on camera whether anything unexpected has occurred, you focus on how well the object fits revised models, not on the fact that those models had to be revised at all. Each choice, taken alone, is defensible. Together, they create what feels like a deliberate atmosphere of dullness, a field in which anyone who continues to care deeply about 3i Atlas is gently nudged toward the margins, categorized as overly intense, compared to the soothing official voice. The imaginative leap comes when we consider how neatly this manufactured boredom serves not just institutional needs, but also, perhaps, the needs of the object itself. If 3i Atlas does hide a dense fossil core, or something more deliberate within its luminous skin, its best defense is anonymity. A brief flash of interest at discovery is almost unavoidable in our current world. But sustained, deep scrutiny requires human attention that must be actively maintained. By helping the public shrug and move on, by framing each new observation as a confirmation rather than a question, institutions become accidental allies in whatever camouflage 3i Atlas may be using. The triple tail can keep its secrets, the post-storm flicker can whisper without being heard, and the core can glide toward and away from the sun under a blanket of carefully curated indifference. No one has to lie for this to happen. They only have to keep choosing the least interesting way to tell the story. There is a softer, more charitable reading that sits alongside this darker one. Most scientists are not trying to hide anything. They are trying to avoid overstating mysteries that may turn out to be mundane. They have seen apparent anomalies evaporate under better data, seen careers damaged by premature claims. In that culture, the threshold for calling attention to something is very high. A triple tail that does not disconnect under a storm, a set of brightness variations that almost look periodic. These may be deemed intriguing, but not yet worthy of a public pivot. Better to wait, to gather more data, to speak only when the evidence is overwhelming. The trouble is that, in a universe where truly alien phenomena may be subtle by design, the insistence on overwhelming evidence can function as its own kind of blindfold. By the time a signal becomes undeniable, the sender may already be gone. From the outside, listening to all of this, from your own dim room, you are left with a peculiar responsibility. You do not have access to raw spacecraft telemetry or closed-door meetings. You cannot compel agencies to change their tone. What you can do is notice how often boredom appears precisely where wonder should be. You can remember that being told there is nothing to see is not the same as proving that nothing is there. You can hold open, gently, the possibility that 3i Atlas is more than the flattened picture presented to you without letting that possibility harden into certainty or fear. As the date of its closest approach approaches in December, official voices may grow even quieter, eager to let the event pass without fanfare. In that silence, a smaller, more patient community continues to watch, tracing the path of a point of light that the wider world has already filed away. The unsettling question that hangs over this stage of the story is not whether a grand deception is being orchestrated, but something more intimate. How much of our ignorance about 3i Atlas is the result of active concealment, and how much is simply the byproduct of our desire to stay comfortable, to let complex, unsettling possibilities fade into the background hum of ordinary life? When boredom itself can be manufactured and distributed like a soft blanket, choosing to stay quietly curious becomes a small act of resistance. In the next chapter of this dossier, as 3i Atlas draws nearer, we will look more closely at what happens when the geometry shifts in our favor and the mask of its luminous skin grows thinner, asking whether even a carefully managed narrative can fully prevent the approaching light from outlining whatever has always been hidden inside. As the calendar moves toward the date of closest approach, something subtle begins to change in the way 3i Atlas presents itself to us. The physics is simple enough. Every day that passes, the distance shrinks, and with it the size of the smallest feature that our telescopes can, in theory, resolve. What was once confined to a few smeared pixels blossoms into tens of them. The coma that used to be a soft, circular blur stretches into an oval where brightness falls off in more complicated ways. The triple tail, traced only in broad strokes before, now reveals thinner filaments and faint gaps where one plume overlaps another. Even without better instruments, geometry alone begins to act like a slow magnifying glass, sharpening edges that were once smoothed away by sheer distance. In that sharpened light, the idea of a mask becomes more than a metaphor. It becomes a structure that either slips or holds. From an observational point of view, this period in December is the moment when everything that has been hinted at has its best chance to show itself. The angle between 3i Atlas, the Sun, and Earth shifts so that sunlight grazes its coma from the side rather than from directly behind. Backlighting, which once turned the object into a saturated disk, gives way to more nuanced illumination, with one edge of the halo slightly brighter and the other gently shaded. Any asymmetry in the distribution of gas and dust, any preferred direction of jets, now casts a clearer shadow into the glow. Space-based telescopes, freed from atmospheric blur, schedule their narrow windows of observation, knowing that the ratio between distance and resolution will not be this favorable again for a very long time, perhaps not within any of our lifetimes. On paper, this is the phase when the luminous skin of 3i Atlas should be at its thinnest, at least from the perspective of our ability to read what is written on it. Yet as those dates approach, the public narrative grows quieter instead of louder. There is no grand countdown to the moment of closest approach, no widely promoted promise of new, sharper images. Technical schedules may be full, instruments may be pointed, but the story being told to most people is one of a slow, uneventful fade. In brief updates, spokespeople mention that 3i Atlas is following its expected path, that observations continue, that further analysis will take time. They do not dwell on the fact that, for a few nights around the 19th of December, the object will occupy a small but precious sweet spot in the sky, far enough from the sun's glare to be studied, close enough that its mask, if it has one, will be stretched tight over whatever structure it conceals. A once-in-a-generation alignment is treated as a footnote, as if the universe had offered a magnifying glass and we had politely declined to look through it. Grounded speculation suggests several mundane reasons for this mismatch between opportunity and attention. Telescope time is scarce, and 3i Atlas must compete with targets that promise clearer scientific returns. Known exoplanets, distant galaxies, variable stars, whose flickers can be translated into precise physical models. Observing committees may decide that an object already labeled and described as a comet does not merit the same priority as mysteries that are still in the process of being defined. Weather, both literal and institutional, plays a role. Cloud cover cancels nights. Budget cycles pull focus toward missions still seeking funding. Communications teams are instructed to highlight successes that can be easily celebrated rather than revisiting topics that some decision makers consider closed. In such an environment, it is not surprising that the richest visual face of 3i Atlas passes with less fanfare than its earlier, more ambiguous discovery. But if you take seriously the idea of a luminous mask, another possibility begins to unfold. Suppose that what lies inside 3i Atlas is not indifferent to our gaze. As distance shrinks and the risk of revealing internal structure rises, there would be an incentive, from its perspective, to keep attention as low as possible. It cannot turn off the sun or stop the geometry from becoming favorable, but it can rely on the habits of human institutions that are already inclined to move on. Perhaps the pattern of outgassing is adjusted to smooth away features precisely during the windows when our sharpest instruments are watching, trading some efficiency in trajectory control for the safety of remaining visually unremarkable. Perhaps any experimental behavior, any testing of unusual jets or field configurations, is delayed until the object has passed its closest point and begun to recede, when each new day turns high resolution back into blur. There is a quieter version of this that does not require intent. Even a natural object with complex internal structure may reveal more of itself under certain lighting and viewing angles. If observations are not dense enough during that favored geometry, if coverage is patchy or interrupted, the most revealing snapshots can easily be missed. A few frames where the coma briefly elongates into a shape that hints at rigidity, a night when the triple tail twists in a way that does not fit standard models, these can slip by unrecorded or be captured only by instruments whose data will take months to process. By the time those frames are studied in detail, 3i Atlas will already be far away, its moment of intimacy with our sun reduced to memory and mathematics. The mask will have thinned, briefly, in a way that might have allowed us to glimpse the core, but no one will have been looking closely enough at the right time and with the right tools. Meanwhile, a different geometry is at work, one that has nothing to do with orbits. It is the geometry of attention. As 3i Atlas approaches its nearest point, the graphs of public interest and internal curiosity move in opposite directions. Among a small network of observers, both professional and amateur, anticipation grows. They refine exposure plans, tweak tracking software, double-check pointing coordinates, knowing that these nights are precious. Among the wider public, interest curves flatten, their peaks long past. Algorithmic feeds, tuned to click-through rates, present fewer stories about a comet that did not crash, did not explode, did not overturn any official declarations in a single dramatic moment. In that mismatch, the mask of 3i Atlas finds its greatest ally. The fewer people who expect anything at all from the 19th of December, the fewer will notice if, in some deep stack of images or obscure dataset, something finally looks a little too sharp, a little too deliberate, to be comfortably filed away as natural. The imaginative leap, as we drift toward the culmination of this dossier, is to imagine what it would mean if the mask were to slip in a way that could not be ignored. A filament inside the coma resolves into a straight edge, sharper than any plausible dust structure. A localized glow appears and moves along the triple tail in a pattern that resists explanation as a random fluctuation. A subtle change in trajectory, too smooth and sustained to be caused by outgassing alone, shows up when pre- and post-approach positions are compared with painful care. Any one of these would not prove that 3i Atlas is more than a comet, but together they would push the story to a point where boredom could no longer cover it. Institutions would have to choose between acknowledging the strangeness or doubling down on interpretations that fewer and fewer careful observers find satisfying. As you imagine that fork in the road, An uneasy question settles beside you. Will we recognize the thinning of the mask if it happens, or will we let it pass, trusting slow, rounded summaries that arrive months later and quietly declare that nothing fundamentally new was seen? Geometry and light will do their part regardless. On the 19th of December, the paths of Earth, Sun, and 3i Atlas will sketch a precise triangle in space that will never be repeated in exactly the same way. What we make of that triangle, how closely we are willing to look at the lines it draws on our instruments and in our imaginations, remains, for now, in our own unsteady hands. There is a moment in every mystery when the world decides it is finished with the story, even if the story is not finished with the world. For 3i Atlas, that moment came quietly. Headlines cooled, new topics crowded the same timelines that had once flashed its greenish glow. Somewhere between the 19th of November and the days around closest approach in December, a collective hand reached out and turned down the volume. The object kept moving, the data kept arriving in silent cascades of numbers. But the sense of shared attention, that brief flare of human curiosity, thinned and then scattered like dust in a tail. What remained were the archives, the algorithms, and a small number of people who were not ready to put the file away. If you listen closely, you can almost hear the difference between those who have moved on and those who have not. Institutions speak of 3i Atlas in the past tense as something that was, an event successfully managed. They refer to it as the third interstellar comet, a phrase that conjures a tidy list rather than a living question. Reports file it between other objects, another row in a table. Meanwhile, in dim rooms and scattered observatories, screens still show fresh plots. Timestamps creep forward. New measurements of brightness, position, and tail structure are added to stacks that may never make the news. In this quieter layer, 3i Atlas is not a closed case. It is a companion that is still in the room, pacing slowly toward the door. Grounded science gives those who keep watching a simple excuse. There is still much to learn about how interstellar objects behave near a star like ours. Small changes in the path of 3i Atlas after perihelion can refine our models of how outgassing pushes on a dense core. Comparing its long-term light curve to those of other comets can reveal whether its activity truly fits the patterns we expect or only pretends to. Yet beneath those sensible goals, another motive hums. For some, continuing to track 3i Atlas is a way of refusing the manufactured boredom that settled over it after the 19th of November, a quiet act of resistance against the idea that something becomes simple just because someone in authority has said so. Watching a tiny streak of light slide across the same patch of sky night after night becomes a ritual of loyalty, not to fear, but to the possibility that the universe might still surprise us in ways our institutions are reluctant to name. The imaginative thread running through this dossier has sketched several possibilities for what 3i Atlas might be. A planetary fossil, its dense core carrying the memory of an ancient world shattered long ago. A sleeping machine wrapped in ice and dust to cross the dark between stars under the cover of a comet's skin. A hybrid of both, geology repurposed into technology by hands we can barely imagine. It has considered storms that charge rather than tear, tails that behave like rigging rather than smoke, small flickers in the data that could be echoes or could be replies. None of these pictures has claimed the status of fact. They are thought experiments, anchored to real observations, scaffolds built to explore what the data might mean if we allow ourselves to ask more than the safest questions. There is a risk in such thinking, and it is worth naming. If every anomaly becomes a narrative about a hidden intelligence, we will eventually lose sight of how rich and strange natural processes can be on their own. Comets really do grow complex, braided tails from nothing more than sunlight, ice, and rotation. Solar storms really can produce subtle, layered responses without any guiding hand. A universe that is entirely natural is already almost unbearably beautiful. The purpose of this exploration has not been to replace that beauty with fear, but to show how thin the line can be between a comfortingly closed story and one that remains open, even if only a crack, to possibilities our current models do not easily contain. Somewhere above you right now, perhaps lost in daylight or hidden below the horizon, 3i Atlas is already on the far side of its visit. Its path is carrying it away, the angle of its triple tail slowly shifting as geometry and distance conspire to turn sharpness back into blur. The luminous skin that caused so much quiet debate will thin and cool until, from our perspective, it is gone. Whatever core it has, fossil or machine, will slip back into the long, cold anonymity of interstellar space. We may never know whether it was truly as simple as the word comet suggests, or whether under different political and psychological conditions we might have dared to say aloud that something about it refused to fit. The window for that direct knowing is closing, measured not in dramatic countdowns, but in the slow fading of its magnitude on a handful of charts. And yet, in another sense, 3i Atlas will not leave us at all. The data it has etched into hard drives and printouts will remain, waiting for new eyes and new tools. Future missions may be designed with it in mind, built to chase the next interstellar visitor with a willingness to ask harder questions earlier. Young students who first heard its name as a casual headline may grow into scientists who look back and see, with clearer hindsight, which details we overlooked and which chances we let slip past. In quiet playlists and long nights, its story may continue to play out in people's minds, not as a source of dread, but as a lullaby about how little we truly know and how gently we must hold our certainties. For now, though, you are here, listening to a voice trace the outline of a mystery that is in some ways already moving beyond us. Your room may be dark or softly lit. Outside, the sky over your own horizon may be clear, clouded, or entirely out of sight. You may never see 3i Atlas with your own eyes, and that is all right. The act of paying attention to it in thought is its own kind of observation. It means that, for a little while longer, this visitor has not been completely folded into the background noise of history. Someone is still awake with it. Someone is still willing to imagine that the skin may not tell the whole truth about the core. As this journey comes to rest, let the tension we have carried start to loosen. The sun will rise and set, whether 3i Atlas was only an icy relic or something more deliberate wrapped in dust. The institutions that spoke too softly or too firmly about it will go on, their choices one chapter in a much longer conversation between humans and the sky. The object itself, whatever it truly is, has passed us without harm. It has left no visible scars on our world, only faint marks on our instruments, and slightly deeper grooves in the parts of our minds that wonder about who else may be traveling through the dark. You do not need to decide, tonight, which version of the story to believe. If you like, you can imagine 3i Atlas now as a small, distant ember, its triple tail thinned into a single, faint line, gliding back into the cold between stars. You can picture its luminous skin finally peeling away in some far-off decade, revealing a core that no one from Earth will ever see, its truth known only to the silence that surrounds it. Or you can simply let it fade, trusting that if there is something important to learn from this encounter, it will find its way back to us through future discoveries, future visitors, future nights like this one. Either way, you are allowed to rest. The sky will not stop being strange just because you close your eyes for a while. So take a slow breath in and an even slower breath out. Feel the weight of your body where it meets the bed or the chair. Let the thought of 3i Atlas drift a little farther away with each exhale, like a point of light sliding toward the edge of a field of view. Whatever wears a skin of ice out there will keep its long, silent course whether you watch it or not. For tonight, it is enough that you have looked and that you have wondered. When sleep comes, let it carry you gently in orbits of warmth and habit that feel, for now, familiar. Somewhere far above those dreams, a visitor is already on its way into the dark, and we remain here under our own thin atmosphere, a little more awake to the thought that the universe may always be wearing more than one skin.